Hello! In this video I'm going to be going over a problem that involves stoichiometry and the ideal gas law. And ironically enough, this problem is very similar to a lab that we often do where we have to experimentally determine R in the ideal gas law. So first things first, we have to write and balance an equation. We've got magnesium reacts with hydrochloric acid forming H2 gas. Our two reactants are magnesium and hydrochloric acid, HCl. And it says hydrogen gas is produced or is formed, so H2. And it looks like we've got a single replacement reaction happening. So the positive cations are going to be fighting it out, and magnesium is going to boot out hydrogen, which is why we got hydrogen gas being formed. And magnesium is going to steal the chloride ion away to make magnesium chloride a salt. So we got to make sure that the overall charge is 0 of this guy. We know H2 is 0, but chlorine's -1 and magnesium is 2 plus. I memorized those, or you can look at the periodic table. Magnesium is in the second column, so it's got a 2 plus. Chlorine's a halogen, so it has a 1 minus. Just one electron away from having an octet, so when it becomes an ion, it's satisfied with a -1 charge. We got to crisscross it. So that 2 goes here, and that 1 goes there. 2 times -1 is -2. 1 times +2 is +2, plus 2 minus 2 equals 0. Alright, and if you're doing the states, H2 is gas. MgCl2 is going to be aqueous in this case. It's a single replacement. This guy's aqueous. This guy's a solid. Alright, forgot one thing. Got to make sure that the law of conservation of mass is satisfied. So what we're going to do is count our chlorines. We have 2 on the product side and 1 on the reactant side. I'm going to put a 2 coefficient to give us 2. Got 2 on both sides now. 2 hydrogens, 1 Mg, 1 Mg. Looks like it's balanced. Now we can get on with this problem and start doing stoichiometry. If 45.6 grams of magnesium react in excess HCl, which would suggest magnesium is my limiting reactant, so I'm going to write down my given. 45.6 grams of Mg, and it says how many liters of H2 gas form. So I got to convert this to moles, do mole ratio. I don't have that buddy sheet up, but if you had it up, there's those 5 steps. Write and balance equation, write down given, convert to moles, step 3. Alright, 1 mole over 24.3 grams, that's the molar mass or the atomic mass of magnesium found on the periodic table. That equals, gotta have a calculator, otherwise you will not be able to solve the problem. 45.6 divided by 24.3 gives you 1.876. 1.876, we're talking about moles of Mg, but we don't want moles, we want hydrogen gas, H2. So I'm going to do step 4, multiply it by a mole ratio of H2, what I want, over Mg, what I'm getting rid of. Where do I get my numbers from? 1 mole of H2 over 1 mole of Mg. It's a 1-to-1 mole ratio. Moles of Mg cancel out. Times it by 1, it's the same number, but the unit is different. Moles of H2. Alright, now it says how many liters of hydrogen gas form at these conditions. These are not STP conditions, so I can't just convert it to liters by multiplying by 22.4 liters per 1 mole. Can't do that. When you're not at STP, you have to use the ideal gas law, also known as Huebner. PV equals nRT. Alright, so we got pressure, 740 mmHg. If you do not know that R, when your unit of pressure is mmHg, is 62.4, then go with what you do know, such as 0.0821, but that's an ATM. We're going to have to take 740 mmHg, multiply it by 1 ATM. For every ATM, you have 760 mmHg. Right, so we do 740 divided by 760, gives me 0.974. 974 ATM. Alright, I'm going to plug that in as my P. 0.9 Let's lower this. 74 atm. My volume is what I'm looking for. My N I found as my 1.86, 1.876 moles. My R is 0.0821, I memorized that. And my temperature is 27 degrees Celsius, but I got to add 273 to convert it to Kelvin. 273 plus 27, 300. So now we're going to solve this guy out. 300 times 0.0821 times this by 1.876. Divide both sides by 0.974. 0.974. 0.974. That looks like it gives me a volume of 47.4. Double check. Sig figs. 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. 47.4 liters of H2 gas is produced. And that is how you combine stoichiometry with the ideal gas law to find an unknown volume.